Hola, mi clase. All right, we are doing 9.5. We're going to solve quadratic equations, so like 9.4, but we're going to use a new process called completing the square. So I can solve quadratic equations by completing the square. So what it means to complete the square is the process of adding what we take our b over, and we divide it by 2, and then we square it, and we add it to our x squared plus our bx to form what we would call a perfect square trinomial, because, right, a trinomial means 3 terms. So it kind of, in a sense, becomes our new c, okay? So it says, what value of c makes x squared plus 6x plus c, we're trying to find c, a perfect square trinomial. So that's where we're going to use our b over 2 squared. And in a sense, this will give us our c, okay, in this term. So we're going to take 6 and divide by 2 squared. That's going to get us our c. So 6 over 2 is 3. And then 3 squared and 9 will be our c. And then so if we take x squared plus 6x plus 9, it would be a perfect square trinomial, because this is x plus 3 squared if we factored it. So that's why it's called a perfect square trinomial, because it's a perfect square itself. X plus 3 times x plus 3 gets me this. These are equivalent. And so that's what our answer would be, is that we would add 9, or c would be 9, to make this a perfect square trinomial. So maybe pause, just try it. Shouldn't take you very long. What would c need to be for this to be a perfect square trinomial? So we would have done 12 divided by 2 squared. 6 divided by 2, nope, it's not 6 divided by 2. That is what 12 is divided by 2, squared. And we would say 36 would need to be c to make it a perfect square trinomial. So that's the easy part. Now using that. So it says, how can we find the solutions of x squared minus 14x plus 16 equals 0 if we're going to use perfect squares, okay? So the first thing we're going to actually do is we're going to subtract 16s to both sides. And we're going to get, oh, I don't want to put that low. We're going to get x squared minus 14x equals negative 16. Now what we're going to do is complete the square. So that's where I'm going to take negative 14. And actually, I'm just going to take 14, not the negative, because it doesn't really matter. I'm going to square it either way. All right, so I'm just going to go 14 over 2. So even if I took the negative, it would be negative 7, and I'd square it. I'll show it to you guys. So I'll do it over here. If I even took the negative 14 over 2 and squared, you're going to see I'm going to get the same thing. So 14 over 2 is 7. This is negative 14 over 2 is negative 7. But I'm squaring them, so you can see either way I'm going to get 49. It doesn't really matter. So this negative part doesn't affect it. If you take the negative, it's fine. If you don't take the negative, it's fine, because either way we get 49. So what we do is with this, we're going to actually add it to both sides. I've actually not changed my problem. Because I added 49 to both sides, it's still the same problem. It's almost like adding 0 to both sides, because I'm adding the same value to both sides, so both sides are still equal. So what we would get is we would get x squared minus 14x plus 49, and it would equal 33. That's what negative 16 plus 49 is. Now we would factor this, but we know it's a perfect square, so it's x minus 7 squared, because I need it to multiply to positive, add to negative, so there's where the negative comes in, and we're just going to square it, equals 33. Now to get rid of the squared, we square root, just like we did in 9.4. We get x minus 7 equals plus or minus the square root of 33. And then what we're going to do is add 7 to both sides. And so we get x equals 7 plus or minus the square root of 33. And then in a sense, to split it up, our two solutions would be 7 plus the square root of 33 and 7 minus the square root of 33. So this is how our final answer could be written as well. And that's just what this means. 7 plus or minus the square root of 33 just means we end up with two problems. We don't need to find out what the square root of 33 is yet. Now, if it asked us to round like to the nearest tenth or something, we would, but this is an okay solution for what we're doing. Okay, so when it says plus or minus here, 7 plus the square root of 3 and then 7 minus the square root of 3, it looks like this. All right, so let's do another one. So we'll go start off by adding 9 to both sides. We'll get x squared plus 10x equals 9. So after this first step, maybe pause here and see if you can complete the square and then see if you can solve it. What's really nice is because it's a video, you can at least do the first step, see how it went, and pause again, and so on. So that would be probably a really good idea. So I'm going to do 10 divided by 2 squared. We get 5 squared, which is 25. So we should be adding 25 to both sides. So we get x squared plus 10x plus 30. Oh, I forgot my 25. Hold on. Plus 25. There we go. Equals 34. This is where I then factor to x plus 5 squared equals 34. All right, it's positive, positive. So square root, we get x plus 5 equals plus or minus the square root of 34. We subtract 5 from both sides, and we get x equals negative 5 plus or minus the square root of 34. Again, we can always write those as two separate problems. Negative 5 plus the square root of 34, comma, negative 5 minus the square root of 34. These would be our two solutions. All right, maybe again pause and see if you can even do any of the steps that I won't even start at this time. Maybe you can try to do these steps. So if you go off what I've been telling you, you should have subtracted 16 first. You've gotten 2x squared plus 12x equals 5,600 because the 16s disappear. You actually can divide all of this by 2 because everything can be divided by 2. So we get x squared plus 6x equals 2,800. This is where I'm going to complete my square. So I'm going to go 6 divided by 2 squared gets me 3 squared, which gets me 9. So this is where I'll add my 9 to both sides. So x squared plus 6x plus 9 equals 2,809. Factor this, x plus 3 squared equals 2,809. Square root both sides. X plus 3 equals plus or minus the square root of 2,809. Now, I haven't checked what the square root of 2,809 is. It might be a good idea to see if it's something that perfectly square roots out. So let's see. Oh, if I square root 2,809, I actually get a perfect number. It's 53. So I'm going to go x plus 3 equals plus or minus 53. Okay, so it's always a good idea to check, is it a perfect square? So then I'm going to minus 3 from both sides, and I'm going to kind of come over here, and I get x equals negative 3 plus or minus this, not the square root of 53, just 53. Now this is where we actually would do two problems. I'm going to go negative 3 plus 53 and get 50, I'm going to do negative 3 minus 53 and get negative 56. And we would actually say our answers are 50 and negative 56 because they come out as a very nice whole number. So try to check these, see if they come out as perfect square roots. It comes in handy, especially for a problem like this. It says, how can you use completing the square to rewrite the quadratic function y equals x squared minus 8x plus 11 in vertex form? So we still need those vertexes sometimes when we solve, and so it helps to put our equations in vertex form. So we're going to still subtract 11 from both sides, just like we would, but now we're going to get y minus 11 equals x squared minus 8x. We're going to still do our completing the square, so I'm going to do 8 over 2 squared, oh, that's a horrible squared, equals 4 squared equals 16. So now I'm going to add 16 to both sides. We're going to get y plus 5 equals x squared minus 8x plus 16. We're going to factor y plus 5 equals x minus 4 squared because it's negative in the middle. And then we just move the 5 back over, and y equals x minus 4 squared minus 5. And look at that, it's vertex form, HK form as sometimes we call it. And we know where the vertex is now. It's at positive 4 and negative 5. So that's how you can use the quadratic function, or use the completing the square to change quadratic functions into vertex form. So the only little extra step is here, we move that number back over. So it says use the maximum, what is the maximum altitude reached by the plane? At what time does the plane reach its maximum altitude? So they gave us this function. This is where that vertex comes in. It says a equals negative 5t squared plus 80t plus 9,000. So I'm going to rewrite this function up here. All right, so we're going to do the same steps, okay? We're going to subtract 9,000. A minus 9,000 equals negative 5t squared plus 80t. We are going to complete the square, so I'll do that over here. 80 divided by 2. Actually, I'm going to show you guys something to make these numbers a little smaller. I'm actually going to pull the 5 out of these right here, and I'm going to take a negative 5 out. So it's going to become a minus 9,000. I'm not dividing everything. What I'm just doing is I'm going to put it here. Go t squared minus, and then 80 divided by negative 5. That's where I'm getting the minus from, would be 16 t. It's just going to make these numbers a little smaller. I can show you, though, that it'll work either way, but I'm going to use negative 16. Like I said, it doesn't matter because when we divide and square, it's still going to come out as positive. So negative 16 divided by 2 is negative 8. When we square that, we get 64. So in here, we actually are adding this inside the parentheses. And so when we add it to this side, we're actually going to add negative 5 times 64. And so that's what I was saying, is that you don't have to pull it out, that it would work either way. So I'm going to show you that here in a second just to show you that it works. But this is probably where it would get a little confusing. So if I used 80 over 2 squared, that would get me 40 squared, which gets me 1,600, right? No, 1,600, there we go. And so you can see that's a really, really big number to be adding to both sides. So So that's another reason we do that, so that we don't have to deal with these such big numbers. I do need to find out what 5 times 64 is. So 5 times 64 is 320. And it's negative. So this becomes A minus 9,320 equals negative 5t squared minus 16t plus 64. We are trying to complete the square, and that's actually why we pull this 5 out. It's because that 5's not going to help me complete the square. I want something that I can square root. And with that 5 in there, I can't square root that. I can't complete the square. So I'm going to take that 5 out so that I can complete this square. That's what I'm trying to complete. So we get A minus 9,320 equals negative 5t minus 8 squared, because it's negative in the middle. And then what we do is we add back this, right, just like we did on the last one to get it back in vertex form. And we get A equals negative 5t minus 8 squared plus 9,320. So this would have messed this vertex up, right? So that's why we need to take that 5 out, because we're actually trying to complete the square here. With the 5, it wouldn't complete the square because we'd have to square root of 5, which isn't perfect. So we pull out this 5. Notice I didn't divide the whole thing by 5. I just left it right here so that I can complete this square. So now that I have it in vertex form, I know that it's at 8 seconds. So it says at what time? And height, maximum height, 8 seconds, max height of 9,320 meters, because I got that off of here, right here. So the vertex form helps us answer this question without fully graphing or trying to guess or whatever. And so that's why we use completing the square to be able to write this vertex form. So main thing to remember is that we want to do b over 2 divide by 2 to complete the square. And we add to both sides. That's a horrible S, but you get the idea. Sides, okay? So here's your independent practice. You just need to write this into vertex form. No finding the solutions, no nothing like that. So just solve this for a vertex form. And for a reference example, it would be this one that we did, okay? So 2 problems back. All right, adios until next time.